Hello everyone, welcome to day 7th of September Leetcode challenge, and today's question is reverse linked list. In this question we are given a linked list and we need to reverse this linked list and return the head of the reverse list. The question seems pretty straightforward. I believe most of you will be able to solve this question by themselves. However, there is another question which is slightly difficult than this question, reverse linked list 2. We have already solved that question in the past. Use this as an opportunity to revise that concept because it was slightly tougher than this, and it will give you a good hold of linked list problems. So I would urge you guys to look at that solution if you already know this. I think you already know this. Just for the sake of consistency, let me just share the solution with you. So moving on to the presentation that I have created. Reverse linked list 1 and 2, Leetcode 206. And in this question, we are given the head of the linked list. We need to reverse this linked list in place. You can't create a new linked list out of this, which is in reversed order. You have to do it in place. So what we will do, we'll start by creating 3 pointers. The first one will point to null, and it is named as the previous node because there is no node before 1. Next we have is the current pointer C, and it will point to the head of the linked list initially. Also, we will take into consideration another pointer which is the next of the current. So what we'll do, we will check what is the value held at current. It is not null. Then we will update the next pointer to point to currents.next. So next points to current.next, and as soon as we have done that, we can update this particular link. So instead of keeping it here, we will update currents.next to point to the previous node. And what am I going to do now? I'll update the previous to point to current. So previous gets updated to this. Simultaneously, I'll update my current to point to the next node because we have to move ahead in the iteration. And the updated state of the linked list is something like this. So we have 1 which is pointing to null. Let me just show it by across, and the reference is held by previous. We have the other part of the linked list which starts at 2, and then it has 3, then it has 4, then it has 5, and the pointer to it is current. So let's continue the process. Let me just change the color of pen for the next iteration, and let's take red this time. So what am I going to do? Let me just store the reference to the next node of the current. So next node of the current is 3, so next points to here. Then as soon as we have stored that reference, I'll update currents.next to point to the previous node. So where is the previous node? Previous node is at 1, and I have updated the link of currents.next to point to previous. As soon as I'm done with this, I'll update my current to point to previous points to this node now for the next iteration, and current points to this node. So what is the state of the updated list? So we have 2 which is held by previous node. Next we have is 1, and 1 then points to null, and let's just signify it by a cross. And the other part of the linked list, we have 3, we have 4, and we have 5. 3 is pointed by the current node, which is appropriate. Let's continue the iteration. Next we have a 3 pointed by the current node. What we are going to do, we'll store the currents.next in the next pointer, and as soon as I am done with this, I'll update currents.next to point to the previous node. So now 3.next points to 2, and once I'm done with this, I'll update current previous with current, so previous points here, and next with current. Next current points to 4 now for the next iteration. So what we have done, we have removed this link, and we have now 3 points to 2, and previous is pointed by 3, current is pointed by 4. And you can continue this operation till the time current doesn't become null, and as soon as current becomes null, that means we have exhausted the complete linked list, and you can simply return the previous node, because as you see that we are progressing in the iteration, the reverse linked list head is pointed by the previous node. I hope you got the context. So without much ado, let's look at the coding section. So moving on to the coding part. As I talked about in the presentation, I have created 3 nodes: previous, current and next, and I have initialized previous to null, current to head and next to null. Till the time my current doesn't point to null, that means we have exhausted the linked list. What am I doing? I am storing the reference to currents.next, and as soon as I store its reference, I update currents.next to point to the previous node. Previous gets updated with the current node, and current gets updated with the next node for the next iteration to happen. After I am done with this loop, we are out of the loop. That means the linked list is exhausted, and we can return the previous node, which will point to the head of the updated linked list. So let's submit this up. Accepted. The time complexity of this approach is pretty straightforward. It takes order of length of the linked list to do the reversal, and no extra memory space because you're doing it in place. So length of LL and SC would be order of 1. This brings me to the end of today's session, but guys, don't forget to view the other solution for reverse linked list 2. I am attaching its link here only. I would highly recommend you guys to go and watch that video, because we are creating opportunities to revise the concepts. It's who have to create opportunities for ourselves. It's not that somebody, Leetcode has to tell us that this is the question of the day and then we are going to solve it. We have to give the right direction in order to achieve our goal. This brings me to the end of today's session. I hope you enjoyed it. If you liked it, please don't forget to like, share and subscribe to the channel. Thanks for viewing it. Have a great day ahead and stay tuned for more updates from Coding Decoded. I'll see you tomorrow with another fresh question. Till then, goodbye.